even ini mahasiswanya nggak terlalu banyak.
Ya, ya Bu.
Boleh mulai Bu kalau sudah mau mulai.
Sensei, how are you, Sensei?
Apa?
How are you? Are you fine?
Yes, okay.
Yeah.
So it says it's going to be live streamed on YouTube. Oh,
Yes, Sensei.
okay.
We will record this meeting. Thank you so much to become our guest lecturer. I think you are so busy, but you give a chance to become our guest lecturer in this event.
Thank you very much for inviting me to speak here.
Yes, Sensei. I'm so sorry also because during 1 year, maybe around 2 years, I don't have any progress to report to you regarding with my topic. I'm so sorry, but
Yokojima Sensei and I are looking forward to your results. So anytime you are ready.
Yes, Sensei. I hope if I have servers, the server is available, I will work again my research, then give you the new progress regarding with my topic.
Okay, great. So the class is graduate students plus undergraduate students.
Undergraduate students, Sensei.
Undergraduate students, okay. And they are going to be teachers with education?
Yes. Yes.
Science teachers at high school or college or all levels of teachers? All classes, all schools?
Sorry, yes. Not just science school, I mean science student, but others field like language, education. Yeah, so it is a multi study program.
Oh, okay. So students from literature are here too. Students who are not in science.
Yes. Some of them, but some is from science education. So, and we said this who wanna more information about the theme of the lecture. So it's welcome for everyone student.
Okay, everyone.
Interested with the theme.
My talk might be a little bit specialized, but I try to explain.
Yeah.
Okay.
Yeah. But it's okay. It's okay.
Okay.
Today, because Mr. Arwar can do it because he has a ceremony for his father-in-law. Just passed away yesterday.
So just maybe just a short time, I joined with this meeting, Sensei. Sorry, my internet connection is unstable.
Right. What did she say? I couldn't. Who is?
Maybe my father-in-law.
Oh, your father-in-law. Oh.
Yes, my father-in-law is passed away yesterday, so.
I'm
maybe,
sorry to hear.
It's okay, Sensei. But maybe only just short time to follow this meeting to say hello to you.
Okay. So you'll be gone?
Yes.
Oh, okay. That's why your mail was very short. I understand.
Yes,
okay, I'm very sorry to hear that.
Sensei, actually, many of my students is interested to study in Japan. Maybe in the last of your talking, you give a short explanation how to if my student go to in your lab, is there any like a student exchange program that can be followed by my students so that they can enter in your lab?
In my lab,
yes.
it might be better to go to Kanazawa University because
Okay.
they have double degree.
Double
program.
degree for goodness.
My university is very small, so you can visit for
Oh,
a week or two.
yeah.
But
Yeah.
a permanent position, permanent place in Japan should be a larger university.
Okay, yeah.
Like Kanazawa University.
Yeah, Kanazawa is
So-
very good, and
Yeah.
I recommend Kanazawa University. I used to work there. So-
Yeah, maybe I will contact Nagao Sensei.
And
Yeah.
Nagao Sensei is very good, and they have very good program, and they also take care of food at the cafe.
Yes. Just
And-
Muslim food.
Yeah, so it's much
Yeah.
better to go to Kanazawa University and then visit our university for a day or two or something like that.
But for visit your university, 1 or 2 weeks is okay. 1 or 2 weeks looking for another program, like maybe there is a Sakura program from Japan. Maybe I will apply. If I pass that program, I can bring my student. Maybe your university is better, I think. Only for 1 or 2 weeks.
We'll try to accommodate if that happens. And
Yes, yeah.
it depends on the student's interest. If the students
yeah.
our university has very specialized pharmacy and life
Pharmacy and
science.
lab science.
So
Yes.
if students are interested, it's good. But then if the students prefer a larger university, you should go to other places. So it depends on the interest.
Yeah, yes, I see.
Okay, I think time is. Pak Sarif is already. Okay. Kita mulai aja ya. Ibu Fani sudah
Bu.
ada ya. Oke, saya mulai aja ya duluan. Ibu Fani ya.
Yeah.
Oke. Nanti bentar. Ya sebentar. Okay. Hello everyone. Okay. May I have your attention please? So, because the lecture is about to begin. Okay. Assalamualaikum warahmatullahi wabarakatuh. And good morning everyone. My name is Purnama Ningsi. I'm a coordinator project of this program. So it's our honors to organize the virtual general lecture series year 5 in partnership with Eurasia Foundation and Faculty of Teacher Training and Education, Tadulako University, with the theme Education of Asian Community. Firstly, I'd like to welcome to our guest lecture for today, for Professor Masako Takasu. Is a proper pronunciation,
Yes.
Sensei?
Yes, very good.
Okay. Okay. Yeah, Professor Masako Takasu from Tokyo University of Pharmacy and Life Sciences in Tokyo. So, good morning, Sensei.
Okay, thank you very much for introducing me.
Yeah. Nice to meet you in the meeting.
Nice to meet you. So
thank you for your being, thank you for.
Thank you very much for inviting me to give me a chance to speak here.
Yeah.
So should I start?
Yeah.
Okay, let me get my...
No.
Okay.
Yeah. Because there's a moderator will guide the lecture, and I just give a welcome speech before lecture start. Okay. We are so grateful that in your busy schedule you can give a talk and share with us here. And I just like to remind to everyone who participate this lecture today, turn off your microphone during the lecture, and don't forget follow the lecture properly and use the raise hand function, or ask when the Q&A session, use the raise hand function, or you can type in chat box. So I think just a little announce for participant. So actually for time efficient, will turn the time over to Miss Fanny Maria Agustina, PhD, to get the lecture today. So Miss Fanny, please, time is yours to get the lecture today.
Okay, thank you for our coordinator of sciences, Ms. Purnama. Well, good morning, everybody. Good morning, Professor Masako Takasu. Welcome to Tadolako University. And today we will hear your topic, very interesting topic. We are so happy as a student, as a lecturer. We are so happy to have you as a Japanese lecturer to be part of our lecture today. And then we are happy as well with the title, your title about molecular dynamics simulation of proteins. This is part of our material as a chemistry background, because the attending for today, especially for the science, most of them as chemistry students, and then some of the chemistry lecture, instead of all some lecture from different backgrounds. And we are so happy for being you today, and then we're so happy to have the new inspiration, the new knowledge from you, Professor Masako. Wow, this is a time that very good. I deliberately to put your city, represent your city for the flower for my background.
Oh, thank you.
Well, okay, ladies and gentlemen, all the participants, today we will hear about the general lecture from Professor Takasu from Tokyo University of Pharmacy and Life Sciences, and the title of the topic about molecular dynamics simulation of protein. Professor Masako, I give you the time around 25 to 30 minutes. Now time is yours, please.
Thank you very much for your very nice introduction. Let me start my PowerPoint. Let's see, here's my PowerPoint. I can't find my PowerPoint. Here it is. Okay, can you see?
Yes, we can see. Yes.
Okay, good. Okay, I'm very happy to be here, and thank you very much for inviting me to give me a chance to speak here. Okay. Excuse me. Okay, first about our university. I'm at the Tokyo University of Pharmacy and Life Sciences. Excuse me. And this is specialized university. We have two departments, Pharmacy and Life Sciences, and I'm at this Department of Life Science. Okay, and this is our group this year. One is missing, absent, but the front 6 young people at the front row are undergraduate students, senior year in college. And the second row, we have 6 graduate students and 2 senseis, professors. So we have 3 professors and those students. Here, Dr. Arwan visited our lab in August 2017. So that's like 5 years ago. He looks younger. And here at the standing at the here is Dr. Aron. I'm here, and other are mostly graduate students. At that time, we had many male students, but now we have more women. And we've already finished sushi party here. Okay. And Dr. Aron stayed for 2 weeks at our university. He was mainly at Kanazawa University with Professor Nagao. And he had, Kanazawa University has a program to send people to other universities. And so he was at our lab. Okay. Okay. So what I'm going to talk about is here at the red part. Well, I graduated from physics department at University of Tokyo, and my PhD thesis was Monte Carlo simulation of a spin model, Heisenberg model on triangular lattice. So I worked in this blue part, physics and computer simulation. But then I did several projects. I worked with several areas. And now, since I'm in life science department, I'm working in this red part here. So it's intersection biology, physics, and computer simulation. Okay. So in the life science department, I teach first year physics to students. And they say, oh, is physics related to biology? And they're surprised to learn that they are related. You know, this Newton's equation of motion in classical mechanics, where it says mass multiplied by acceleration vector is equal to force. And in high school, you learn this equation with large objects, such as you throw a ball and ball falls with gravitational force, or you have spring, it's going back and forth, and then Earth and Sun, for example, have gravitational forces. But this equation is not just for large objects, but also for small objects. If you have the force is different for what you're working on, but this equation holds for small objects like molecules and atoms. Okay, so in that case, F is intermolecular forces or electrostatic forces and other forces, but still for small things, this equation holds. And my first year students are surprised to hear that, oh, really, this MA equal F it applies for our body? Wow, but it applies for our body. Okay, so that's what my molecular simulation is doing using this equation. And in physics, we learned that acceleration is derivative of velocity, and then velocity is derivative of position. And so this equation is actually a differential equation, and we know the force, but we don't know where the particle is. So we solve the differential equation and get where the particles are or what velocity they have. So this is very basic equation. Okay. So I want to talk about two topics. They are both molecular dynamics of proteins, but first one is related to myopathy, which I will explain. And then the second one is branching enzyme derived from this one. Okay. So both are done in our group by graduate students. Okay. So the first one is this. The calculations are mainly done by Mr. Nakajima, who is a PhD student in our group. And this work is in collaboration with Professor Hayashi, who is at Tokyo Medical University. since myopathy is, well, first studied by Professor Hayashi, and we became interested in myopathy. Okay, what is myopathy? The characteristic symptoms are muscle weakness. So as well, this occurs around teenager or later. The muscle becomes weaker, and no fundamental therapy has been established. And some people found that 4.5 limb domain protein called FHL1, well, if there's a mutation means a wrong amino acid from the wild type, and then this is one of the factors in presenting symptoms of myopathy. So in other words, if they look at patients having myopathy, weaker muscle, then they sometimes, not always, but sometimes find mutation, wrong amino acid in FHL1 protein. Okay. And this is about FHL1. So this protein is involved in muscle growth, structure maintenance, and signal transduction. And the structure is like this. It has so-called 4.5 units of limb domain, and this gray one here is zinc. So zinc, it has a characteristic of having zinc, and it's called limb 1, limb 2, limb 3, limb 4. Each limb having 2 units with zinc, so-called zinc finger. And those circles are amino acids. And limb domain has cysteine-rich zinc finger structure, and this zinc finger contribute to the stabilization of the structures of protein. And where are the mutations, which are the wrong amino acids? And if we look at the reports of the myopathy, we find many cases with mutation in the second limb domain, limb 2. So this seems to be a very important limb. And where are the mutations? This is limb 2, and there are 2 zinc atoms. And here are the positions where in some cases of patients, mutations are found. So our research is to analyze property of mutant limb domain with zinc binding. And well, we try 2 models, zinc binding and non-binding models. So here again, we have MA equal F, where A is now written as a second derivative of the position Ri. I is the atom. And this is a basic Newton equation, and we solve this numerically. We put F, and we want to get R to know how the structure of the protein are. And this is a technical matter, so I might a little bit skip, but we need force, and it's called force field because there's a lot of force depending on the position, and there's zinc amber force field, so we try to use them. But some of the mutated ones are not included in the already given field. So we try to do some quantum mechanical calculation to obtain the force. And let me see. Okay, so for quantum mechanical calculation, we start with a small model and get some force field. Okay. Okay, so with those potentials, we do the calculations. And there's a software called GrowMax, and this is free software. You don't have to pay. You can download, and there's tutorials that teaches you how to use them. And we use this GrowMax, and we put some ions to neutralize and then start the simulation. We measure some quantities. This is root mean square deviation, where we calculate the deviation of the coordinates with respect to reference coordinate. And in our simulation, the reference structure is at the 0, the first configuration. We also measure root mean square fluctuation, RMSF, and this indicates which residue of the protein are fluctuating. We have, for the residue I, amino acid I, we subtract the average over time and then square it and then add over time and divide by the time length. And we look at the RMSD and RMSF. And in this plot at the left, the horizontal axis is time. And for RMSF, the horizontal axis is residue number. And for RMSF, we found peaks of fluctuation at certain residues. And the structure looks like this. And those 3 lines are for different independent runs. And for the mutated ones, RMSD, well, the structure looks like this. And we look at the RMSDs. And for another mutated ones, we also compare those results. So what we find is this: in the zinc binding model of C150Y, changes in structures and fluctuations were observed in the mutated zinc finger. But in the non-binding model of C150Y, zinc fingers are somehow twisted. So let's see. We looked at this part. Okay, so this was about the protein of the related to myopathy. We also look at another example of our simulation. This is done by master course student Naruyama here. And this is in collaboration with Professor Fujiwara in our department. They are doing experiments and we're doing simulation related to their experiments. Well, actually in our department, there are like 20 something labs. Out of those 20, only 2 are working on the simulation, computer simulation. All the others are working with experiments. So we are sometimes asked to do simulation of these experiments. And so we are in a very good position to have opportunities to look at interesting experimental results. Okay, so Professor Fujiwara's group is working on branching enzyme. And here we have some branches like this. Straight lines becomes branched like this. And this branching enzyme is used industrially to improve the water solubility of starch, the stability of its aqueous solution. And well, the optimal temperature for this enzyme to exhibit enzymatic activity is low temperature, 20 to 30 Celsius. And starch becomes less fluid and less reactive at low temperatures. And well, so they want design a branching enzyme that is active under higher temperature conditions. And here's this red alg here, cynidioxazone merolaya. It's hard to read. And they are found at hot springs, 45 degrees. And they have diameter of this. Okay, so, and they look at the ancestral sequences and look at protein thermostability. Well, because ancestral organisms lived in hot environments. And during evolution, structurally stable regions have been conserved. It's considered so. So, so if we introduce the ancestral sequence into the current organism, we can make the protein maybe thermostable. Okay. So this work was done by Professor Yamagishi's lab. He's a former colleague of ours in the department. He retired right now, but this is shown in his great work. So in Fujiwara's lab, in collaboration with Yamagishi's lab, an ancestral sequence is introduced into the branching enzyme derived from this to improve the heat resistance. And they tried several and found high temperature here. So they know which sequence gives a higher temperature. So our lab does simulation. We analyze the structure wild type is original one, and ancestral sequence mutant using coarse grain molecular dynamics simulation, all atom molecular dynamics simulation. Coarse grain means several molecules are put together as one. In the coarse grain model, we made initial structure, and there's a Martini force field, and we, starting with this atom model, we made this into coarse grain model. Then we look at those results and compare the plots. And we analyze how they aggregate and look at the shortest distance between the box 2 where the mutation is introduced and the C-terminal residues. And we also look at all atom MD simulation. Okay, so we for all atom simulation, we have 3D structure, and then using that, we get the initial structure for mutated protein. Again, the basic equations here, and we look at those quantities. And there are several ways to get the initial structure, and we trust those. And for example, for RMSD, mutated one is in red, and they show larger fluctuation. And RG, which is the size of the protein, is around similar. And for RMSF, we have higher fluctuation at this end. And we also look at hydrogen bonds. So the results are following. We prepare the mutant conformation for initial condition MD simulation, and we performed all atom simulation. And RMSD and RG show similar trend, and hydrogen bonds are formed between N-terminal residue and the sequence introduction site. Oh, it's hard to see this part, so let me look on the Zoom. So let me look at my P. Okay, so the fluctuation at the N-terminal residues are larger in mutants than in wild type. So in the future, we want to increase the temperature of the simulation. Okay, so I showed two kind of results of our group, and which uses molecular dynamics simulation of proteins, and this simulation is based on Newtonian equation of motion, ma equal F, which is very useful. Okay, thank you very much.
Yes, thank you very much, Professor Masako, for your presentation. Very nice, very good, but a bit difficult for us to have more understanding about your working with all the things with the enzyme and then all the things with the course of, but it's very interesting, actually, very interesting.
Thank you.
For this time, I will give opportunity for all participants to have a question to Professor Masako about the material that he already presented to us. So anybody who want to give a question, please just raise your hand or just directly to speak, right? Silakan Bapak Ibu atau adik-adik mahasiswa, ada yang akan ditanyakan, bisa dalam bahasa Indonesia, bisa dalam bahasa Inggris. Silahkan mengangkat tangan, just raise your hand atau directly question, please.
Maybe I have a first question.
Our head of department, Miss Dr. Purnama Ningsi, will give a question for you, Professor Mas. Please.
Yeah.
Purnama.
While we waiting for thank you, Ibu Fani. While we waiting for others participant who has a question about the topic. So my question is, what's actually the general application of molecular dynamic simulation, Sensei?
General application. Oh, other than proteins, you mean?
Yeah.
Oh, okay. Thank you for the question. Well, actually, molecular dynamics simulation can be applied to anything governed by ma equal F. So in my case, I present the results of proteins because I'm in life science department, so I should work on a life science matter, but it's not limited to proteins. It could work to small things or large things. Well, in college physics, first year college physics, we work only on solvable models. Like if you have an object, you drop it and there's gravitational force and you can solve it analytically. But as the number of objects grow, you can't really calculate it analytically. So if anything cannot be calculated analytically, you can calculate by computer m equal F and with not just one particle, but a lot of particles, you can use molecular dynamic simulations. For example, it could be, for example, there's, well, this is also molecular dynamics, but for example, we learn friction coefficient at the first year college physics. you have a floor and you drag something and there's friction force. But this friction, if you look at in molecule level, it's very interesting. It's small particles are somehow they touch the floor and they are off or on, or they kind of give around. So you could use molecular dynamics to anything with MA equal F, especially for complicated matters. If it's only one object, you can usually do it if the force is not so complicated. But if you have like 100 objects or like gas or liquid, and liquid is also good area to put molecular dynamics. What will be your interest?
Yeah. So actually, we can apply this molecular dynamic simulation method with drugs. Is that right? With drugs.
Drugs.
Yeah.
Yes. DRUG. Okay.
Yeah. We can, apply this simulation also. Yeah.
Yes.
Yes. Yeah. Okay. It's actually very, yeah. Because as you know, our faculty, we have just a disaster a couple years ago. So our instrument, especially our laboratories, have a big what I have to say is yeah, we lost many infrastructure. So the problem is the instrument of our laboratory. So maybe, yeah, I give back to Ibu Fani. Maybe any others participant who has a question for this topic.
Thank you,
Sensei.
Thank you.
Yes, thank you, Ms. Purnama. Okay, well, I'll give opportunity for the others who want to have a question. Just raise your hand or just speak directly, please. So if somebody want to have a question, please. There is 127 participants today, 127, yes, participants. So if you have any question, so yes, before, yeah, they haven't raised hand or ask. I will ask the question before that. If somebody still prepare, I will ask a question for Professor Masako. So this is regarding with the myopathy, yeah, right?
Myopathy. Yes.
Myopathy, right? Myopathy. So if you connect it with the I read for your background, you say that for the journal say that about the muscle weakness, right? Muscle weakness. So when you make this one, it's regarding when you want to produce the drug, right? So how it working? Well, how it's working to regarding with the muscle weakness based on your research. So we just want to know more about that. But you talk about this protein VHLI, and then how the application for the muscle weakness, how we can see about the symptoms, but using what you make it or what you research, how it's made for the muscle one. So just want to have the general idea regarding with the health, right? So I know that you work in the small things, but regarding with this, how we can characteristic with the symptoms, right? So we just want to have like the clear information or the clear understanding with the myopathy regarding what our health, the muscle weaknesses symptoms.
Okay, thank you for the question. There are many kinds of myopathy.
Yeah.
And type that Professor Hayashi, our collaborators, Professor Hayashi is working is a certain kind of myopathy. The number is not so large, and there are other myopathies with more patients. But the type with FHL1 is a smaller group of myopathy. And well, with larger number of patients, the drug companies will probably work on. But for small number of patients, the drug companies are not interested. So that's what universities should do research. So that's why Professor Hayashi and our group are working on it. Okay, so it's certain type with FHL1 with not so large patient. But for one patient, it's terrible. The muscle just weakens. And well, actually the life expectancy of the patient is not so bad. It's similar to average. So the patient will continue to live, but gradually the muscle weakens, he cannot walk, and then he cannot sit, and so on. He lives, but it's terrible for him. So that's kind of myopathy and small number of patients, and that's why we are working. And Professor Hayashi's group are trying to, studying the basic of the patients, and we are not at the level of finding drugs. But if we look at the basic properties of FHL1s and how the proteins, what's wrong with the mutated proteins, well, you could say FHL1 is important and then mutation is bad. But well, that's true. But we want to see why mutation is bad, how it affects, and there are several types of mutation. Which one is really bad? And if we can look at the behavior of the proteins, then it may be we haven't devised any drugs or anything yet. But if we look at the basic properties, maybe we or someone can come up with candidates for drugs or something like that. But we are not at that stage yet.
Oh, that's great. So yeah, I understand we are not directly to have the drugs, but the basic thing you working with the protein, right? The domain protein that will work, it's working or not, in order to have how to reduce the symptom of the muscle weakness, right? So it is very interesting actually. So what you're working really helpful for the pharmacy, especially for the drugs. But the basic thing, the protein working, the behavior and all the things you already explained is very good to us to understand. And that's very good. Yeah, we are very happy to have some topic like this to get more understanding. Yeah, thank you, Professor Masako.
Thank you.
If anyone want to have a question, oh yes,
Yes.
Dr. Arwan Shah, please. Time is yours to have a question.
Yeah, thank you so much for moderator giving me chance to give a question. Sensei, sorry, I just see your the end of the slide. I see there is a mutation in the protein sequence. You do a research for mutation in the sequence, the protein sequence. Would you like give a brief explanation why do a mutation in the protein sequence and how to validate that mutations in the protein sequence is stable or not?
Can you, about the mutation, can you repeat the question? You have two questions?
Yes, I have two questions. Why you do a mutation in the protein sequence? What the function do mutation in the protein sequence? And the second is how to validate the mutation, the created model from the mutations of protein sequence is stable or not. Sometimes if we do a mutation, the protein will break. So I'm interested about the stability of the proteins mutation.
Okay. The first question is function of the mutation.
Yes, Sensei. How mutation the sequence?
Function of the mutation.
Yes.
Oh, function of the mutation. Well, our research is like this. For the Professor Hayashi's lab gets patients with myopathy. It's rare disease, but they're specializing type of myopathy. So patients come and they check and see the mutation. So, and the function mutation is in general, it varies. Sometimes, as you say, the structure may be broken. And sometimes it might be just a little bit change of structure. It will depend. And for the stability, our simulation is not so long. And to see it really destabilized, it will take many simulation time. So we are looking at the first, starting with somehow similar structure to the wild type. We are looking at the first stage, since the simulation time is not so long, first stage, and see if it has a tendency to be unstable or not. So we cannot look at the whole picture. The chains breaking down is a very long time-consuming simulation. And we might have to coarse grain or something like that. But in our case, we are looking at the first stage of the unstable or stable part.
And one more, Sensei. Have you checked the conformational chains? Have you compared the conformational chains of the protein between wild type and mutations part?
Yeah, that's RMSD.
By RMSD.
And well, actually, it depends on the runs. If we do independent runs, the mutated ones sometimes similar to the wild type and sometimes not so. So it varies.
Okay, thank you.
But since the initial configuration is we use the wild type and add the mutation. So we are using wild types configuration to start with. So the question is how far it goes from the wild type. And we can't look at the whole time, so we look at the initial time.
So you compare the conformational change from the initial state to the end of the state.
Yeah, and the initial state is obtained from the wild type.
Okay, understand. Thank you, Sensei.
Okay.
Okay, thank you, Dr. Arwansyah, for your question. Well,
thank you.
Yeah. Do you anybody still have a question, please? Just raise your hand or directly to speak. Or if you want to ask in Indonesia as well, it's okay. If you understand a little bit, just ask in Indonesia, please. For the student, ayo adik-adik berani memberikan pertanyaan atau buat dosen-dosen silakan. Kami persilakan mungkin ingin tahu lebih lanjut atau adik-adik khususnya yang adik-adik yang interesting di bidang kimia, biokimia, protein berhubungan dengan biokimia. Ini hal yang menarik sekali tentang, silakan. Pak Suherman mungkin, Pak. Ada pertanyaan, Pak Suherman. Silakan adik-adik, ada yang mau bertanya. Nggak usah malu-malu. Ada sesuatu yang ingin ditanyakan, entah secara umum atau secara detail, tidak apa-apa. Yang penting berani bertanya. Kami ini generasi muda harus betul-betul punya semangat untuk question, bertanya. ini bagian dari critical thinking loh. Silakan adik-adik atau anybody who want to have a question dari luar program studi kimia, silahkan. Just wait, Professor, we asking for the question, especially for the students. We asking in Indonesian. So just motivation for them to, please adik-adik, jika ada yang akan memberikan pertanyaan.
Ayo bertanya. Kalau ada yang bertanya, saya kasih hadiah
Oke,
untuk
ini
mahasiswa.
ya ketua jurusan lagi memberikan motivasi nih. Siapa yang bertanya ada presentnya, ada hadiahnya, ada rewardnya, please. Ayo, mana nih? Berto, siapa lagi? Dia, Rani, sudah apa? Silakan bertanya. Mana si Berto ini sering bertanya dia. Ayo, silakan bertanya supaya semangat kita boleh ada. Ini orang Jepang nih, ada yang mau studi lanjut ke sana. Pertanyaan apa aja yang berhubungan paling tidak secara umum atau secara boleh secara detail, please.
Tanya tentang Jepang juga boleh. Silakan.
Professor Masako, some of them a bit, a little bit shy to ask.
Okay.
Because the background as well for understanding about the material. But if somebody want to ask a bit, asking about the Japan or your university is possible?
Yes, yes.
Okay, that's great. So please, the student, you can ask the general question for about the study in Japan, because this most of students have the class about the Asian situation. Asian, yeah, please. Octaviana, are you going to ask the question, please? Ya. Silakan, siapa yang akan bertanya berhubungan dengan cara belajar atau situasi suasana pembelajaran di University of University from Professor Mosako, University of Pharmacy and Life Sciences in Tokyo, right? In Tokyo. So if you have any question regarding with the life of university in Tokyo, please just ask question. Ayo adik-adik, ada yang bertanya tentang.
Let me tell a little bit about Japan.
Yes,
okay.
Please, Professor.
I came to my university in 2009.
Okay.
So that's like 13 years ago. And before that, I was at the Kanazawa University.
Oh, Kanazawa University.
And
okay.
that's on the coast closer to China. And it's about 3 hours by train from Tokyo. And Kanazawa is a very nice place. You can eat very good fish, and the climate is a little bit cold in winter, but not that much. And they have Kanazawa University, where they have a lot of students from Indonesia. They have double degree program, and they also and usually you find at least several students from Indonesia. So that's one of the good places to visit. And well, to come to Japan, you first have to have funding. So you apply to government money, and you first have to secure the funding. You have to maybe take exams and things like that.
Yeah.
After you get funding, then you look for which university. And I recommend Kanazawa University. It's a very good, they have all kinds of departments, science, engineering, literature, economy, law, a lot of computers, and a lot of departments. They have, it's from the Kanazawa station, you take a bus to go to the Kanazai University. It's in the mountains and very beautiful place. So I recommend.
Okay. Yeah, very good, Professor, for information. So, Kanasa University salah satu university yang direkomendasikan oleh Profesor Masako, because dia dekat dengan Tokyo dan view-nya juga bagus sekali, dekat gunung, bahkan banyak mahasiswa Indonesia yang kuliah di sana. Dan beliau merekomendasikan, mungkin karena beliau tahun 2009 dari sana, dari Kanasa, dan pindah ke Tokyo University untuk farmasi ya, dipindah ke sekarang ini. So sangat bagus sekali informasi ini. Jika ada yang ingin studi lanjut ke sana, Kanasa University salah satu recommended yang sudah diberikan oleh Profesor Masako. Oh, very good. Very good information about that. So I still have yes, this one question. If no more question, okay, there's the chatting here. What's the chatting say? We see the chatting. Yes. Okay.
Just for student.
Yeah, in Indonesia, please. They want to ask, but in Indonesia, please. Yeah. Okay, please.
Izin Bu.
Yes, Liberty, please.
Liberto.
The undergraduate student will ask to Professor Masako. Liberto Repi, please.
Ya Bu. Saya mau bertanya. Mohon Bu pakai bahasa Indonesia Bu.
Okay. Translate.
Saya mau bertanya kepada Profesor. Kira-kira dari Profesor sendiri bagaimana tips atau cara mudah untuk dapat memahami materi tentang biokimia ini, khususnya untuk biomolekular protein ini. Karena menurut saya, ini salah satu materi yang mungkin agak sulit untuk kita pahami sebagai mahasiswa, Bu. Sekian.
Okay. Thank you, Liberto. Professor Masako Liberto asking about the topic, your topic about the molecular, especially for biochemistry, right? So how the tips we learn about the topic, especially for the specific for your topic, and then especially for biochemistry. So how the tips you can give to them, how to learn very easy, or the good way how to learn about this material. So you can, if you can, something that you can share to us, please. Yeah.
Tips about learning what? Biochemistry or computer? Yes. Or?
Yeah, biochemistry regarding with the material, because they feel a bit difficult as to understand, you know, regarding with this topic. Yeah.
Okay. If you're interested in general biochemistry, or well, a very good book is The Cell, written in English. The Cell. Do you know the book? It's in my bookshelf. I have to walk to get it. But there's a very good book. Please wait.
Okay. Yes, please. Don't worry. Jadi ada cara yang dia untuk kamu pelajari tentang spesifiknya tentang sel apa yang ya, ada buku yang dia ingin tunjukkan ya.
Okay, I majored in physics, so biochemistry is not my field. I had to study. Okay, so this is a book, The Cell. It's written in English, and it has all colored pictures and things like that. It's written by who? Alberts. This, and I was in Canada University when I started learning about biochemistry, and I gathered several graduate students who are willing to study. We assigned one chapter for one graduate student, and well, we didn't go all the things. We did the basic first part of the book, and each one prepared a chapter, and then write down resume in Japanese, of course, and then we gather. It was during summer time, and we gather one day, and from 9 o'clock in the morning to 6 o'clock in the evening, each one has 1 hour to present the what he or she learned. So we sort of crammed for the biochemistry, and it was very interesting. People, students liked it. They prepared very hard. So if you want to study something, get together with your friends, about 10 people, 6 to 10 people, and they each one presents the part he or she studied, and you all learn by it. So, my tip is to form a study group.
Okay.
And you can share your ideas on how to learn, and instead of studying just by yourself, it's much more practical to study by group. And the cell book is very good.
Okay, that's great. That's great. I speak Indonesian. Bagus sekali untuk menjawab Liberto. Ya, jadi caranya profesor itu misalnya diambil yang buku tebal sekali ya tentang sel ya. Ini bicara tentang biokimia ya, bro. Walaupun backgroundnya bukan biokimia, tapi profesor ini belajar juga biokimia yang berhubungan dengan fisika ya. Dan ternyata cara belajar itu dia kasih buku dan bukunya itu dibagi-bagi per chapter. Dibagi per chapter ke mahasiswa dan mahasiswa itu mereka pelajari translate dalam bahasa Indonesia, dalam bahasa mereka ya. Mereka pelajari satu chapter per chapter. Nanti pada musim tertentu, musim panas, mereka dikumpul kembali dan mereka akan menerangkan satu persatu apa yang chapter yang sudah diberikan itu untuk terangkan masing-masing ke untuk didiskusikan ya. Jadi setiap chapter itu mahasiswa mempresentasikan dan bertanya, dan ini suatu model pembelajaran yang memberi mereka pengertian yang dalam sehingga betul-betul mereka kuasai ya. Bayangkan per chapter adik-adik. Jadi satu buku itu per chapter dikasih pelajari nanti bulan depan pas musim libur atau musim apa ya, kumpul baru presentasikan masing-masing. Itu luar biasa ya. Itu salah satu tips ya. Salah satu tips yang Profesor Masako lakukan untuk bagaimana memberikan kemampuan pembelajaran khususnya dalam bahasa Inggris ya. Karena itu kan materinya bahasa Inggris semua. Untuk mereka kuasai dan mereka presentasikan dan mereka paham, dan dikatakan kalau belajar sendiri oke, tapi lebih powerful kalau kita belajar kelompok. Belajar kelompok itu penting sekali karena masing-masing bisa memberi ide, masing-masing bisa, dan ini bagus sekali ya. Bisa kita praktekkan ya, seperti itu ya. Yes, very good input, Professor Masako, about learning chapter by chapter in one book, and then they can share by themselves in every summer. You say that, oh, very, very nice. Yeah, for discussion and understanding as well, because from English, right? So very good.
Thank you.
Okay, so about the time we near, for the 10 o'clock, I think it's enough for our speaking today, our talking today with this great guest lecture. We are thank you for your presentation, Professor Masako. Thank you so much for this time. We have the new inspiration with the new understanding, but very good for us. Right, and again, on behalf of as a moderator, we thanks a lot for this time, and Bapak-bapak, Ibu-ibu, demikian presentasi Profesor Masako kita sudah ikuti ya. And now time I give back to Ketua Jurusan, our head of department, Science Department, Ms. Purnama Ningsi.
Thank you very much.
Okay, thank you Ibu Fani. Okay, silakan panitia siapkan ininya. Okay, yeah, Professor Sensei, I've been visit Kanazawa because you mentioned about Kanazawa before. I have visited Kanazawa twice. It's a nice place, and I visit also Kanazawa University, like in the hilltop area. It's very nice and very quiet. Yeah, the fish is a good. And I went to market and
yes,
bought some fish and cook. And the second time it was typhoon, so I just stay at my brother Apato. Yeah, but nice. Okay. So again, it's our honors to have you as a guest lecturer, Prof. Masako. I think our participant in lecture today is really enjoy your lecture. And so here I give the certificate and souvenir from our faculty for your valuable thoughts. It will be sent to Tokyo soon. Hopefully, you can receive it in good condition, because it's a souvenir from wood. Hopefully, it's okay when we
call it-
ebony ebony from a black wood and any certificate. Yeah, I so we will send it to your address, maybe in your university. So please give us your home address or university address. So we will send it. So again, thank you very much, Sensei. Success for your next program, your research, and hopefully our student also can join the program or can continue their study in Japan. So, thank you very much.
Thank you very much for giving me chance.
Sensei, thank you so much.
Thank you so much.
Sensei, thank you so much to become our guest lecturer. And also, please send me regard to Yokojima Sensei, Morikawa Sensei, and other lab members.
Okay.
Thank you.
Thank you very much for giving me chance here. Thank you.
Thank you.
Okay, thank you.
Okay, student, don't forget to fill the absent. In the chat, you can find it in the chat box. Silakan mengisi absen. Okay. Dan jangan lupa besok kita masih ada masih punya 2 kuliah lagi di jam yang sama besok yang akan dibawakan oleh Ibu Diani Rizda dari UPI.